Assalamu alaikum wa rahmatullahi wa barakatuh. This is going to be the hydrates and combustion video, which is also the continuation of the empirical formula, which was already covered by Mahmoud Sameh. If you haven't seen that video, it is strongly recommended as that video covers a lot of strong principles and basic principles that are going to be used in this video, all including moles, molar mass, and the similar. And of course, this is Kareem Gamal, and let's start. Simple explanation for hydrates and combustion very quickly. Hydrates, specifically hydrated ionic compounds, are named by the ionic compound they contain, followed by the word hydrate, which is preceded by a prefix or the coefficient inside the equation that indicates the number of water molecules the compound contains. So that's just the hydrates part. Usually, as already stated, the coefficient is going to be the prefix, and you're going to need to find that coefficient in order to answer the question. And that's usually the format of the hydrates, but in rare cases, you'll find there are other questions. As for combustion, combustion reactions occur when a hydrocarbon reacts with oxygen gas. Thus, all combustion reactions have a set equation consisting of carbon and hydrogen, redacted subscripts, reacting with an oxygen molecule to yield carbon dioxide and dihydrogen monoxide or water. And about the redacted subscripts part, carbon and hydrogen, they each have one subscript that is not given, and that's what's usually going to be answered inside the question. You're going to be needing to find the subscript for each one. And of course, it reacts with an oxygen molecule, so it's usually CXHY. Those are the redacted subscripts. Reacting with O2 to yield the arrow carbon dioxide, CO2, um, and dihydrogen monoxide or water or H2O. That's it. So starting off with the first question, we have hydrates. When a 3.22 gram sample of an unknown hydrate of sodium sulfate, and the coefficient or the prefix H2O is heated, H2O, which has a molar mass of 18 grams, is driven off. The mass of the anhydrous sodium sulfate, which has a molar mass of 142 grams, that remains is 1.42 grams. The value of X in the hydrate is, and so here he just wants us to find out how many molecules of H2O or water there are. And there is a format to answer these questions, and I have it right here. Okay, so we're gonna just take a look at the question and pull out the givens. We have the original sample, which is 3.22 grams. Water is not given, however, we can subtract it. We have 3.22 and we have 1.42, and 1.42 is the anhydrous or like not water. So usually when handling hydrate questions, there are like two like percents, or there are two ratios, and one of them consists of the anhydrous sodium sulfate, not related to water in any way, and H2O, which is the hydrate itself. And usually one of the two are given so that you can subtract it and find the other one. In this case, anhydrous sodium sulfate, the mass is given, and so it's 1.42, and so we can subtract 3.22 grams by minus 1.42 gives us 1.8 grams. And so now we have the anhydrous mass and we have the mass of the water. Using these two, we can go to the periodic table and get the molar mass, and we can get the number of moles of each one, which puts us one step closer to finding the coefficient. And so how do we calculate the moles and how do we find the moles? We take the grams, which is this number and this number right here, and we divide them by their molar mass from the periodic table. And so water, it's H2O, H has 2, oxygen has 16, 16 together is 18, and that's how 18 is right here. And sodium sulfate is the exact same thing, but it's a larger process. So 0.1 over 18, basically that's how you get, oh sorry, no. 1.8 over 18 gives you 0.1. And as already stated, they are obtainable from the product table and the mass is given from the question. We repeat the same process here. We do 1.42 over 142 and it gives us 0.01. And the final step after obtaining the moles, so now we have the moles of water, 0.1, and we have the moles of the anhydrous sodium sulfate, which is 0.01. The final step here is to divide the moles of water, which we've obtained, by the moles of the anhydrous sodium sulfate, which is right here. And so it's 0.1 over 0.01, and that gives us 10, which is the coefficient or the prefix, and it is D. The answer is D. That's question 1. Question 2, which also covers hydrates. It states a student is assigned the task of determining the moles of water in 1 mole of magnesium chloride and the prefix H2O or the hydrate. The student collects the data shown below, and just a tip from me and you, I don't want you to be alarmed by the table. I know it's a lot of numbers and I know that it seems like kind of confusing, kind of vexing. However, like once you start to pull out the givens and once you start to subtract, it's going to be much, much easier. And so let's cover the first question. It says, explain why the student can correctly conclude that the hydrate was heated a sufficient number of times in the experiment. Now, what he means here is that why doesn't the student need to heat it more times than three? Now, the answer to this question is because if you take a look at the values after the first heating, the second heating, and the third heating, the intervals between them, they're very, very minor. So there's no reason for it to be heated a fourth time because it's just going to be very similar. The precision here is very close. And so 23.982, there's a difference of 0.006, and then there's a difference of 0.001. So the student feels that there is no need to repeat the experiment because of the precision of his experiment in heating. Now that is question A. Question B, it needs some calculation, so we're gonna pull out another sheet, and it says explain why this. No. It says calculate the total number of moles of water lost when the sample was heated. That's A. All right. So first we need to, as done with the previous question, we're gonna pull out the givens, and so the container alone is 22.347, and if you realize all of these include 22.347, and so subtracting all of these by 22.347 is going to make everything much, much, much easier because the numbers are big, the numbers are confusing. You can just, like, if you have the time to make it like easier for yourself, you can just subtract all of these by 22.347. Anywho, the original sample is 3.478 because we have the initial mass of sample in the container. You subtract 25.825 and 22.347, you get this. And similarly, you can do that with water. But first, you're going to pull out the anhydrous because anhydrous is given first. 1.63 grams, that can be given by subtracting the mass of sample and container after third heating by container. And so you're going to have 1.63. Now, with this 1.63 grams, as stated before, there are two sides to the equation. There's the anhydrous side, and then there's the hydrous side, or water, or the hydrate. And so you've got 3.478, subtract 1.63, and you get 1.848. And so now we have what we need to repeat the steps of last question. And so we're just going to use the water and the anhydrous magnesium chloride and obtain the moles of each one so that we can get the prefix, because once again, the question is the exact same. It's of the same essence. So moles of water, it turns out to be 0.103. As stated before, you take the grams of water from the sample, which is 1.848, and you divide it by the molar mass of H2O, which is 18, and you get 0.103. And after that, you've got the moles of the anhydrous magnesium chloride. Turns out to be 0.017. Once again, you take the 0.103 that we've gotten from the previous section, and then you divide it by its molar mass from the periodic table. Chlorine is 35.5, and so that's 71. 71, and magnesium, if I'm not mistaken, is 20 something, I can't remember, but the total comes out to be 95.3. And so dividing 0.103 by 95.3, that gives you 0.17. Once again, you take the moles of water, which turns out to be 0.103, and the moles of anhydrous magnesium chloride, 0.017, and you get approximately 6, which is the coefficient or the prefix. And so once again, I just want you to realize that after we took out the givens and we used the format that we used before, the question became much, much easier than just looking at the values and being confused, being frozen. That's it for the second question.